Okay, so in this session, we will understand what are the challenges we face in running Hadoop in production, some of the best practices. So we will discuss a problem and we will see, okay, how we get rid of that and how another problem comes in, and in production, how we can handle those kind of things. And then in the end, I will just quickly talk through skills required to be successful in big data. And why I need to talk about that, I will probably tell you at that slide. So let's look at what are the challenges. First, we will look at vendor diversity. We have so many vendors in the market which has both positives and negatives. So we'll look into that, how things could be positive and negative. So second question we will look at, is Hadoop really needed, right? So here I will not be talking about those three V's, right? Volume, velocity, and all, which everybody talks about. So I will be talking about why you should use Hadoop, right? So I will be kind of pitching it against that you should be using Hadoop only as a last resort, right? Which will be very counterintuitive to my profession, because I am running a consultancy into big data and also trainings, but still I'm saying do not use Hadoop, right? So I will explain you what I mean by that. So current state of Hadoop development and admin tools. Then we will look at what are the challenges within an organization, and we will also look at lack of performance visibility, right? So when some of the users say my Hadoop cluster is running slow or my job is running slow, so how you define that slow. And in the end, we will talk about a little bit on the skill sides. So let's look at vendors first of all. So there are a lot of vendors in this market currently in the Hadoop space. So major one among them are Cloudera, Hortonworks, Mapper, and there are many other vendors like IBM, Oracle, which run their own Hadoop. So one first thing, the positive thing about it is it generates a positive competition in the market and gives the users more choices among the platforms to use. So it kind of forces the vendor to give a better product. But let's think from an end user perspective. I'm an organization. I'm going in for a Hadoop in my company. Which vendor I will go with? I will go with Hortonworks, whether I will go with Cloudera, whether I will go with Mapper, right? So that making that choice could be really very difficult. Okay, in some cases I can say, okay, I will not use Mapper because it it is a kind of a closed system. It has something proprietary. I have to pay license fee, lot of things. On the other side, it also has advantages, right? For example, Mapper is giving you high availability from the day one, right from Mapper MapReduce 1, right? From the day one, they are giving you high availability, which no other distribution gave you, right till when Hadoop 2 was introduced, right? Which we call Yarn framework. On the other side, how will I make a decision between whether I should use Cloudera or Hortonworks? Both are excellent products. So again, it depends upon what is your main inclination towards a product within the company. For example, I may be using a development stack which is more closely suited to Cloudera stack, right? For example, I might be more inclined towards using a Impala, which is a Cloudera product, right? On the other hand, I might go by a market review in which people might say, okay, Cloudera Manager is slightly buggy, right? It has improved a lot over the years. And other thing is I might look for some use cases. For example, as most of the participants are from India, so they might be aware about the Aadhaar product, or the Aadhaar project, I should say. So they started with Cloudera, but it couldn't scale to the requirements they had. For example, the data size they had, the number of hits they had, and their SLAs. They were sub milliseconds. So Cloudera couldn't scale. So they went with Mapper. They started with Cloudera, ran it for a few years, couldn't scale, moved on to Mapper. M7 for them, M7 is what? It's kind of a improved version of HBase rewritten in C. So it worked very well. So another thing I want to bring to the note is, so aim of this session is not for the beginners of Hadoop, right? I will not be talking about anything basic here, like what is a name node, what is a data node. I will not be talking about that. So this is more about what's currently going on in the Hadoop space in the real production world. So now the very important question comes: is Hadoop really needed? Right? So first question is, we should keep the solution as simple as possible. If I make things complex, right, they might look cool from a technology perspective, but it will be really, really challenging to manage, and it will cost you more, right? You might have heard the very common misnomer in Hadoop that Hadoop runs on cheap or commodity hardware, which is not true, right? If you might have seen in any of your organization, even within your companies, it doesn't run on cheap hardware. There are a lot of things you have to scale up to run Hadoop. But how it might help you in reducing the cost overall, that's a different case. But we should first of all understand, do we really need Hadoop? So how companies evaluate? What they try to do, they try to fit Hadoop into any problem they have. They start with a mindset, can we have Hadoop in our company or not? Rather than that, you should be saying, why I need Hadoop? You should be starting with a mindset, do I really need a Hadoop to solve this problem? And there's a very interesting survey or statistics in the market that 90% of the projects fail because Hadoop was never required in that organization. That work could have been done by simple tool, right? If you can do, let's say, a text parsing, you might do very well with a Unix script, awk, sed utilities, or let's say you might write an RPC program in C for a data transfer clients, right? So you need to understand when does Hadoop should kick in. Let me give an example. So this example which I'm about to give you is really from a company, but I cannot name you the company. So lack of planning or skills is not the reason to move to Hadoop. Let's say you have a DBA in your company and he keeps the database running for a very long time. It keeps on growing out of scope because it was not partitioned or sharded properly, and there was no archiving policy in place, right? So it grew so big, like one database grew to 1 terabyte, right? So it's not a big data problem, right? It is a problem that it was not managed correctly. So most people associate big data by saying, oh, I follow those 3V model, so now I can have big data, but it's not. So do not implement big data to look cool. That's the first rule of a success in this domain. So let's look at how actually the Hadoop journey starts in any company or any project for that matter. You always start with a POC, which is a proof of concept. You start small with few nodes. You familiarize yourself, the infra team and the development team, okay, what Hadoop is, right? So POC should not be done on a laptop, right? If you want to do a POC with one laptop, there's no point in using Hadoop, right? So you don't have that much data. So you start always with a kind of a POC where you might be okay uploading some data from your traditional systems, RDBMS, maybe it could be an MySQL, it could be Oracle. You upload data using some tool, let's say a Scoop, or you might upload logs using Flume into Hadoop ecosystem, and you do some tests on that, and you say, okay, it's a cool thing, we like it, and it can make things good for us. So now the POC is successful. You pitch your idea to the management saying, oh, POC is really good, we can do cool things. So let's build Hadoop cluster in our organization. So what they do, they take some spare hardware they had in the company, right, which was lying around, they put together and start a Hadoop cluster. And they buy few newer machines. Let's say I set up a 40 node cluster, starting with that's my first cluster in my company. I buy new hardware with, let's say, 8 core, 120 GB RAM, and some disk drive. And I take the old hardware which was, or the old servers which was lying around, and I put them into Hadoop cluster. Now my 40 node cluster is ready, right? So how I quickly make a decision, okay, I will say, okay, let's give the powerful nodes or the newer machine to the masters, like name node, the secondary, or the HBase, and spread rest across the slave nodes, right? This is how typically the planning works in Hadoop world, because Hadoop is still very new into the market. So what I will do, I will have a Linux team with me. I will say, can you tune OS for me? And I will read some blogs, read some best practices, and quickly tune Hadoop parameters, set up monitoring by using Nagios, or let's say Ganglia for metrics collection, and my cluster is ready. New cluster is up, and I'm pumping data into it. Everything is fine, right? So it looks cool. But after 6 months, the data size and the number of jobs and also the users who are using Hadoop increase. And now your cluster starts taking hit. Why it might take hit? Because out of the 40 nodes, I have 20 old nodes, which are almost one third the capacity of the newer machines, right? So they will be slower in performance. So all the jobs going to those nodes will take hit. So when the nodes going to those nodes take a hit, obviously the overall job performance will go down. So what I can do, I I may tweak in certain things. I may say, okay, let's reduce the disk space usage. I may put in compression, right? But what it will do, it will increase my CPU utilization. So in on one side, in trying to save the disk space, I enabled compression, but it took a hit on my CPU. You see that data is not equally distributed. Why? Because as I said, old machines and new machines, they perform differently. Disk drives, different speeds, different disk geometries, because different vendors, newer hardware will have a little better technology as compared to the old hardware. So now my machines are taking a hit. So let me see, anybody has anything till now, right? So let me explain you this, for example, quickly, what I mean by this. So let's say I built a 40 node cluster in which I had about 20 nodes which are new, and my other 20 nodes are old. Old means the CPU is, let's say, 4 core, the newer machine has 8 cores. This has slower hard drives, this has faster hard drives. So what will happen when I'm submitting a job? All the jobs which are going to these nodes will be running slower as compared to what are going on these nodes, right? So let's say I submit a job J1. That job will be split into tasks, right? It may be a map task, it may be a reduced task. So this task may go to a faster node, other tasks may go to a slower node, right? So the overall execution time for my job J1 will be defined by the slower node, right? So it kind of now having a kind of an unequal distribution across my cluster. So now we see that the same jobs which were running reasonably well 3 months back are now taking a hit to finish, because now the amount of data has changed, the number of users have changed, right? So what I do, I go back, raise a hardware rack. Hardware rack means requisition, right? So within a company you called it as a requisition. It's a process where you raise a request and request for new hardware. So I will say to my management, oh, I need finance for new servers because I want to replace old servers to add more power. Okay, so let's say it gets approved. Normally the hardware rack process takes a lot of time. From the time it gets approval till the time you order servers, till the time they are shipped in and you put into your cluster, it may take some time, but still, let's say take an assumption, it everything is put into place very quickly. So things are, I'm happy, my cluster is now back, it's doing very well. As the time goes by, so now the business which was using Hadoop, they started liking it, as it is giving insights into what they never had before, right? Before they had to play around with only small set of data, but now because of Hadoop, I'm running a 40 node cluster, powerful machine, I can play around with bigger data. Now business is saying, oh, that's cool, okay, so we are liking Hadoop, now we want to do more things with that. Instead of giving us, let's say, a weekly jobs or weekly aggregation on data, we want monthly or a quarterly aggregation or reports, let's say a sales report or a marketing report. Now again my cluster need changes, because initially I was doing processing on a job, on a workload which was segregated for daily basis, hourly basis, but now I may be doing it for weekly, monthly, or a quarterly basis. So the amount of data I need to process in one go will increase. So now what I can do, we add new nodes, scale the cluster, right? I again add nodes, scale the cluster. So as the business gets critical, because the, if I keep on moving things onto Hadoop and my higher management starts using it because it's giving them reports, the market view, so that projects becomes critical, right? Critical not from maybe from a technology perspective, but from a business perspective. It might still not involve money, but it's critical because your higher management has a visibility over it. So what you do now, you plan for failures. I don't want that my cluster should fail when my, let's say, CEO or a CTO asks me for a report. So I quickly go configure HAs. I configure HA for name node. I configure HAs for resource manager, right? Everything is set up. Now things are going fine. All of a sudden, some critical job is running, which takes, let's say, 14 hours to complete. After 10 hours into its running, my resource manager, which is the master, fails over, right? Fails over means switches to the another resource manager because I have configured high availability. So here I'm giving you a kind of a production scenario. I'm not saying resource manager is failing and I had only one node. I'm saying it had a high availability. So it switched over. Now, what will happen to the job, the things which has run for 10 hours, right? Do I have a history server which keeps a track? What was the state of the job? What will happen to the jobs which were, or the tasks which were running at that moment when the switch over happened, right? So again, the users might ask why my job restarted from stage 50%, right? So many times you might see your job goes to 50%, 60%, all of a sudden 0% again, right? So there are multiple reasons. Speculative execution is also a reason, but that's a different thing. Now your cluster is running multiple jobs, 100 jobs a day, and everything is fine. And one morning, let's say you need some critical sales report. You run the job and it takes forever to complete. Why? Because at same time other users are also using, right? I cannot say, or I cannot control that which all users can run job simultaneously at a time on a cluster. I can control what users can use in a cluster, but I cannot say that when user 1 is running, user 2 cannot, right? Although he can submit, but he has to wait. So I run the report and see it is not finishing. Again, I quickly go check my monitoring. I check my ganglia graphs and my nodes are showing high CPU utilization. That's strange, right? Because I have enough capacity. I have planned for it, right? Because that's my planning set. That's my Hadoop capacity planning set. Okay, I need 40 nodes. I have already added few nodes as well after that. I had asked for more money to increase my servers, but still it is having high CPU utilization. So what is the problem? So investigation shows that CPUs are waiting on network, right? So I never planned for that. Means I have built up my Hadoop cluster, but I put up my Hadoop cluster in the network, which was kind of a legacy, right? My company was using a network which was mainly designed for, let's say, a web servers or the normal kind of a traffic. I put up my Hadoop cluster in that. My network cannot handle the traffic, right? So again, problem. So what I do now, I again go back to the design board, engage the network team, right? So they agree, right, to increase the capacity by giving us, let's say, some spare switches and routers. They ordered few months back. So they said, okay, let's say you have few, we have few spare network components. We give you, you put into your network. I'm again happy. I say, okay, things should work fine now. I quickly reevaluate Hadoop parameters to make sure uh, it gives me the optimal performance, and I upgrade my network. Again, things are happy with occasional node failures, which is very true to Hadoop. So now as the popularity of Hadoop grows within an organization, now people get to know about cool things the other business unit is doing, right? So this, let's say this cluster might be set up for one unit, maybe let's say marketing. Other business units came to know that they are making use of Hadoop and they are doing very well. Now they also want it, right? So we say, okay, fine, sure, fund us some nodes, right? Let's say whenever somebody approaches you, it's not that even if you are a part of the same company, there's a budget allocated to each business unit within a organization. Let's say marketing will have some budget, finance will have some budget, R&D will have some budget, right? So a technology department will have some budget. So initially, the cluster which I set was more of a POC point to, I have set up that from a technology perspective as a kind of an innovation project, right? To show, okay, we are with the latest technologies and we are using Hadoop. But as it get popular, I cannot spend money from the quota of my technology department. I have to ask whoever needs it, I will say fund me nodes. So what they do, they say, okay, fine, we will fund you 50 nodes. So now when they are funding me 50 nodes, again I have to think, what should I do? Should I give them a separate 50 node cluster, or the 50 nodes which they are giving me, I should add them to my existing cluster and share the cluster with the company, with the entire organization. If we set up an isolated cluster, does every PU gets a new cluster, right? Let's say sales guys say, we give you 50 nodes, set up a cluster for us. Tomorrow, another BU comes, say, okay, we will give you funding, set up a separate cluster for us. So what will be the problem? When you have too many clusters, it will kind of generate silos. You might have duplication of data, right? It's a problem called data bloating. Means I may have multiple copies of the same data, production data, in multiple places. And also, if I need to exchange information, it will be a problem. Also, from an technology perspective and manpower perspective, it will be challenging to maintain so many different components, because let's say I want to upgrade Hadoop from one version to another, I have to do separately rather than doing one go cluster in one go. And another challenge will be, if I start giving every business unit their independent clusters, will be how will I differentiate between a production cluster, a dev cluster, a QA cluster, or a kind of a sandbox, right? Let's say I give a 4 clusters, production clusters. One I give to sales, other I give to marketing, let's say other I give it to R&D. Will they directly put their code on the production cluster, right? Which will be very risky. So again, I have to give them a cluster where they can test, do a QA, and then move to production. Then again, it will be a problem. So again, I have to give 2 set of clusters to each business unit, right? So I will increase my complexities. So this is kind of a debatable decision I have to make, whether I should keep one cluster or multiple clusters. So as things grow, you might have different business units coming with requests to use Hadoop. Let's say finance comes and says, we sponsor you 50 nodes. Investment banking says, let's say we sponsor you 70. And similarly, other departments say, we sponsor you, let's say 60 nodes. So now each business unit is sponsoring a node, sponsoring some part of the cluster, right? They have invested into something. So I need to guarantee them a minimum capacity. I have to give them an assurance that you have sponsored me 50 nodes, let's say finance. Whenever you need to run your job, I guarantee you that you will have a capacity of that 50 nodes available to you. How I do that? I have to again go back to my design board and do queue job planning, right? So I have to set up queues in Hadoop. I will say, let's say Q1 for finance, Q2 for sales, Q3 for marketing, and I will assign capacity to each queue, 10%, 15%, 20%, and that's the minimum guarantee I give them according to the investment they have done. If nobody else is using, they can use the entire cluster. But now, see, we started with one POC, and as we are going ahead with the Hadoop cluster, you see how the complexities are building. Now, okay, I'm fine with queues, but now how will I control who can submit to that queue? What if a user from sales department comes and he submits to the finance queue? He's using his capacity. How I control that? So I have to put up ACLs, control on the queues. Again, complexities. How I control the storage on Hadoop? Let's say I have 500 terabyte capacity for my Hadoop cluster. I do not want that out of that 500, 300 is used just by finance. I have to configure quotas. I will assign quotas to each department. And within each department, I have to again take care of what can be used by each user. For example, I create a queue for finance and I say I give you 20% of my cluster resources, but just one user of finance use that entire 20%? Or I have to again do a scheduling within the queue, right? I may use a capacity scheduler for the cluster, and within a queue, I may again use a FIFO or a fair scheduler within a queue, right? So you have a capacity scheduler which is running globally on your cluster, and I can have a fair scheduler running per queue or a FIFO scheduler running per queue. So see, the complexities keep on going up. Each business unit has a different use case. They have different SLAs. Let's say finance might be running very critical things. Let's say a fraud detection or anomaly detection on credit cards. I cannot ask them, okay, I will run your job and you will get output tomorrow or after 12 hours, right? Similarly, sales and marketing will have different job requirements. Can we use MapReduce for all these use cases? No, definitely no. For example, let's say finance case, when I'm doing fraud detection and anomaly detection, I cannot use MapReduce because it's a batch processing system. So now I need to think about Storm, maybe a Spark, a Kafka, right? So now again the question comes whether I will put Storm, Spark, Kafka, all these components within the existing cluster, or I will set up new clusters, each one, let's say for Storm, another for Spark, another for, let's say, a combination of Kafka and MapReduce. What about the different input formats? Let's say somebody might be using text, others might be using Parquet, and another user might be using Avro. How they will be submitting jobs? Because as your cluster is growing, your organization is growing, the number of users on the Hadoop cluster is growing, you might have thousands of jobs submitted every day. Will everybody go and say Hadoop jar name, class, input, output, submit a job? No. How will I do scheduling? Again, you introduce some kind of a scheduler, let's say Uzi. Uzi has its own complexities. So you need to again take care of all these things. Right? So you again go back to the design board. Now you plan for real-time RT, batch processing, maybe a visualization tools. Again, do a walkthrough each parameter to make sure they're fine, because let's say the parameters for Spark will not be same when I'm running a MapReduce on a cluster. So I need to take all these things into account. I might be setting a separate cluster with different set of parameters for a RT cluster and a different set of parameters for a MapReduce cluster. My nodes might be having different capacity. So let's say I already had a 60 or 70 node cluster running. Somebody says we want to run RT, real time. I said, okay, fine. Let's put powerful machines within the same cluster. I buy new hardware, 512 GB RAM, let's say 40 core nodes, put it into the cluster. They have SSD, means solid state drives rather than simple HDD, simple magnetic drives. Now, when you submit a job, how will you make sure that the job goes on that cluster or on that nodes? What I mean by this, let me explain you. Okay, I have a question here. Pawan is asking, how are you going to set HA for master? HA is high availability, right? So I think, Pawan, we have talked about this. I have given you a demo as well in my previous session where we have talked about how we can set up HA. But I will share you a link at the end of this session where you can refer my GitHub. I will share you my GitHub, which has all the configurations, all the steps which you will need to set up all the components in Hadoop, like HA, Uzi, Zookeeper, everything. Okay, so let's say what, let me explain you what I was referring to. So let's say I have a Hadoop cluster. I have a node in a rack, node 1, node 2, let's say another rack. I have, let's say, node 1, another node 2, and let's say node 3, right? All are part of same cluster. So let's say this is a powerful node with 512 GB RAM and SSD, and this is also 512 GB node. This is all part of same cluster. Let's say cluster 1, single Hadoop cluster. I submit a job J1, which is a real-time job, RT job, right? It may be a Spark or a Storm. How will I make sure that job runs on these powerful machines? Right? By default, I cannot control that because that is all controlled by the master resource manager. It will it will automatically allocate containers based on locality of data and also the availability of resources. So how I control that? So there's a concept called label based scheduling in Yarn. It got introduced from Hadoop 2.6, in which what happens, I can say when I submit a job, it should go to these nodes. I can set up storage policies in which I can say run this job only on the nodes which has solid state drives. Right? This is all available in Hadoop from 2.6. Right? So I can control storage policies. I can do label based scheduling. So now for real time clusters, my network could again be a bottleneck. Although I have upgraded my cluster after talking to the network team, because my network devices might not support jumbo frames. What are jumbo frames? By default, the Ethernet MTU, which is called the maximum transmission unit, is set to 1500 bytes. Right? To be precise, 1496. So the packet cannot be bigger than that. But in Hadoop, we talk about large data, larger packet, larger block size. So what will be good if we can transfer larger bytes or larger packets across network? So there's a concept called jumbo frames. In Hadoop, we enable jumbo frames. So jumbo frames are equivalent to 9,000 bytes. So I can send packets up to 9,000 bytes, but my network should support. Let's say I have a switch connected to my server, and on server, if I enable a jumbo frame, but this switch does not support, that packet will be dropped. So again, I might have provision more switches and routers, but do they support running with Hadoop? Right? So being an architect, you need to take care of all these things. So Hadoop administration or setting up Hadoop is not just making a name node and a data node and making them run, right? There are a lot of design issues which you need to take care, and many things we come to know once your cluster starts running. You see, oh, this is a problem, this is a scalability issue, I cannot scale it further, right? Lot of issues will be there. Another problem, how about monitoring? How quickly can I detect an error? If I have a bigger cluster, larger number of jobs running on it, how quickly I can detect an error? How quickly I can find, okay, what all containers or what all tasks got launched for a job. Okay, we have tools like, let's say, a Splunk, which can aggregate all your logs, but they will still not help you with troubleshooting, right? Why a container failed? Okay, because the memory was less and all. Or how you will process Hadoop logs, right? So let me show you an example what I mean here. So let's say I go to my Hadoop cluster. So let's say I have a Hadoop cluster which has a lot of jobs running, and few jobs were running slow or they failed, and I want to do log analysis. So what is the best way of doing log analysis? So I can use, for example, I'm giving an example from my practical experience. I upload the Hadoop logs into Spark and use Spark to search for errors, right? Let me show you what I mean by that. Right, so I have a Hadoop cluster running. So first thing what I need to do is, there will be a lot of logs which Hadoop will generate, right? Let's say it may be a name node log, it may be a data node log, it may be a job log, right? So in Hadoop you run history server, which collects, once the job complete, it what it does, it segregates the logs from all the nodes into one place on Hadoop, right? If you enable a history server, for example, let's say I have a data node 1, data node 2, data node 3, data node 4, I may have a name node. I submit a job, let's say job J1, and its job file is job.xml, right? It's job config file. And that job ran here, some part container ran here. Once the job is complete, what it does, the, till the time the job is running, all the logs are written that local system, to that local system on non-HDFS space. But the moment I configure history server in Hadoop and enable log aggregation, what it will do, it will aggregate all the logs for a job. Aggregation means this log is for a container which ran here. This log is for a container which ran on this node, but both of these containers were part of job J1, right? So let's say if I want to troubleshoot J1, I have to go to each node and look into the logs if my history server is not running and log aggregation is not enabled. So what log aggregation does, after the job complete, it copies all the logs to an HDFS location. It's a configurable location. I can give any location. It puts into HDFS location and I can fetch logs from there. I can convert those logs into JSON by using a Ruman tool, right? So Ruman is a tool which is inbuilt into Hadoop, right? I'm not sure how many of you guys have used this. RUMEN, it's a tool which is used to convert your Hadoop logs to a JSON format. For example, let's say I do Hadoop fs-ls, and I say, let's say temp slash on Hadoop. Let's see what I have on Hadoop. Right, under Hadoop yarn, this is the folder where I've done doing log aggregation, but you can choose any folder you want. Let's say I have staging. In staging, I have a history folder. Sorry, spelling is wrong. History. Right. Inside history, I have a done folder. And within done, I have, let's say, an yearly folder. And within that, I will have monthly, daily kind of a thing. Right. So let's say within that month, all the days on which I might have run a job, I may choose, let's say, 09. Right. I can choose the topmost directory. Let's say I want to see or analyze all the logs for 8th month. I can choose that. So what I will do, hyphen recursive command I will give here. This is the parameter we will give to it. And what will be my command? Let me remove Hadoop fs-ls. I will give the path of the jar user lib Hadoop. So this will vary according to your installation, wherever you have set up home directory and all those for Hadoop. This is a tool called ruman hyphen the version dot jar. I'm running this tool, and what class I'm calling inside this, I can call, okay, I don't remember, let me recall, this org dot apache dot hadoop dot tools dot ruman dot trace. I think trace is capitals, or anyway, if it will give an error, I will correct it. Trace builder, and I will give a name of a file, any file location, let's say slash tmp slash job dot json. Right, so what it will do, it will collect all the logs from this directory. If I don't give recursive, it will just look in this directory, and if there's nothing, it will just give you an empty file. But if I give the recursive option, what it will do, it will go into each directory, look the history file and the job XML file for each job, and create a JSON out of it and store it at this location. Right, it will store it at this location. What I can do, I can upload that JSON into Spark. Let me show you. I go to Spark. Right, you are using Spark for log analysis of Hadoop. Right, so this will be maybe a separate Hadoop cluster which just runs Spark. It does not run anything production data or anything. It's just used for log analysis. So what I do quickly, I create a Spark context, and I load that file job.json. Right, so you can see it has created a data frame. Automatically it creates a data frame for JSON the moment you load it using read.json. What I will do, I can register that JSON as a temporary table, and I can query that as any other table. Now it is, see, you can see it is telling me this job ran has these many tasks. These tasks for map, or let's say I want to search for, let's say, whether those tasks were successful or not, right? So it's showing me these jobs ran these tasks, they were successful. So I can look for successful, failed, how many mappers launched per job, what nodes they launched on, right? So I can parse these things. So this will make things quicker in Spark, right? But you can use any two you want. Yeah, sure. I will share all the commands. Sure. I will share all these commands. The video is also recorded. I will upload the video as well. Right. So another thing, for example, let's say I want to find out what is my cluster utilization, or let's say some node is slow. I can use any tool I want. Let's say RStudio. I think I have a sample. Let me quickly see here. I have sar.csv file, means sar Unix sar command, which gives you statistics of your cluster. What I can do is quickly I can upload this sar file into RStudio to see what is going on in my cluster. For example, sometimes looking at the numbers in the log does not make sense, but if we can quickly graph that to see, okay, how are my nodes performing at that given time, I can do, let's say, read.csv, and I can read that path slash uh, desktop slash sar.csv. Let me check whether it's loaded. I say view, and then I say sar, right? I can see that file. So let's say it's giving me so many metrics, like at this time I have 28 core CPU. This is the user space, system time, this is idle, right? So this is giving me idle. So let's say I want to calculate what is the CPU utilization. So what will be my CPU utilization? I can say sar dollar used, right? I define a new variable. I say is equal to, my utilization will be 100 minus idle, right? So here this parameter is saying idle. If I minus this from 100, that will be my utilization. So you do not see that column here, but it will be automatically created once I execute this command, right? So I can say sar dollar x dot idle. See, so now it has given me CPU utilization for my that many cores. I can plot it. I can say plot on x-axis, give me, let's say, a sar dollar time. I want to see on at what time my cluster had what kind of a load. Sar dollar used. See, so it is giving me a representation here in the graph. I want to see the frequency. I want to see like which nodes were having high utilization, how many times. I want to see a frequency. I can by default do histogram gives me a frequency. I can do sar dollar used, right? So the point of this session was, Hadoop administration is not about just running a simple cluster configuration, and because in when you're on job, there are a lot of skills you need to carry that scripting background, you might have as a system admin, which will help you in doing your work or your little bit programming skills as well. So as you've seen, as the time goes, complexities increases and user might ask for different tools. Somebody might say, okay, I need Apache drill. Somebody might say, I need a Platform, Tableau, right? So you need to have stringent policies or standards within the company saying you can have only these tools, right? There's no point on having multiple tools for the same thing. This is the point I was discussing about. If you build too many clusters, there will be multiple copies of the data and you will have silos. Challenges will be how you will move data from traditional system. Let's say you have an Oracle, MySQL, how you will put data from those into Hive. User says my job is slow, right? What is the definition of slow? Is data node slow? Name node slow? What is HBase compaction causing it slow, right? What is the issue? Is Spark querying taking long? Is the issue with Tej, or is the data duplicate in Hive, right? So you will be seeing multiple issues as you go along in Hadoop. Now, when you are having so many multi-tenants on a Hadoop cluster, multi-tenant means multiple views or users on a Hadoop cluster, you have to take care of security, take care of isolations. For example, I want to make sure that the finance data is not accessed by a sales guy. I have to take care of authentication, maybe Kerberos LDAP. I have to encrypt the data on REST, means when you put data on HDFS, it should be encrypted. What about the data when it goes over the wire? Let's say in the map reduce phase, the reducer will fetch data from mapper over the wire. Should I encrypt it? Right? Should I mask my data? Right? All these challenges you need to take care. So as you grow in the Hadoop journey path, you will see how you started from a POC, and each step when you scale up, you will encounter a new problem. So the current challenges in the market or the issues or the problems we face is like lack of metadata management tools. Name node metadata, FS image, I edits, right? Only Hadoop can see that. We don't have any management tool outside the Hadoop environment which can quickly restore, recover metadata. BI integration tools, there are a lot of integration tools, but still it gives you a lot of challenges. The old business intelligence tools, they do not integrate very well with Hadoop. So you have to do a lot of workarounds. How you will provision a Hadoop cluster? You need to know provisioning systems, let's say a Puppet, Chef, right? So just having Hadoop admin skills will not work. When somebody says my cluster is slow or talks about performance, you should be able to understand what does it mean, because there's always a lack of performance visibility, because slow has a different definition according to different users. So you should be able to understand that quickly. Another problem is within a company as well, you do not have a common stack. Let's say one business unit might be using Java, other might be using a Python, another might be using a .NET, and their set of libraries they might be using will be different. Their coding practices will be different, right? The life cycle of the project will be different. So you need to have a standard within a company to ease out this. So before getting into Hadoop or adoption, it is important certain things are streamlined to make the life easy. So there is a very important law, Moore's law. Everybody might have heard. So what was Moore's law? Moore's law was for semiconductors, which said every 18 months the speed of the processor doubles, right? So you will have every 2 years you will almost have a processor which will be double the speed what you had 2 years back. Similarly, you have a Moore's law of big data, which is a very good one, right? So the amount of nonsense packed into the word big data doubles every 2 years. So this is by Mike Pluta. Very good quote. So you need to understand that and take off that nonsense, right? Whenever you are into Hadoop field or big data domain, you have to shed, because you can do things many ways, make things complex, putting by unnecessary component, making complex pipelines, but keep the noise to minimum. So now coming back to skills, as I've given you a demonstration, right? So just being a Hadoop admin will not help. You need to have a good understanding of the system, mainly a Linux system, a scripting. You should understand, okay, how you can quickly maybe visualize something. Especially Hadoop administrators, they cannot be freshers. They need to be system admins or system engineers before taking a dive or a jump into Hadoop administrators. Big data developers, let's say a Java developer, he starts as a Java developer out of a college. The change in the landscape is not much coming to Hadoop, although he needs to understand the distributed platform and all those, but the change will be very less. So I will recommend you watch another YouTube video at this link, which will give you an insight into what I meant by this. Because the main aim of this session was, I see many of the youths going on wrong track by following a lot of the training institutes, because they will say, okay, learn big data because it's the upcoming thing and all. That's true. But you need to understand, just doing a course will not help you. You need to have certain skills, build up your skill set to be successful. Right. So this is what I talk in that. So you can reach me anytime for any sort of help or guidance. Right. It's not about I charge or anything. It's free. You can reach me on this email. So we rather than just providing trainings, we provide solutions as well on Hadoop. So feel free if you have any questions regarding to in regards to the career prospects, how you implement a technology or anything. I will be more than happy to guide you or help you. Right. So this is what I have in the session, and I will share you few useful links which will help you. So let me share you first of all my GitHub. So this is GitHub, which will which you can use for anything related to Hadoop. Like as Pawan was asking, if you go to this HA, Hadoop and HAQM, you will find all the configuration, how to set up all these things, how to set up Spark, how to tune it, Hadoop 1, Hadoop 2, how to set Kerberos, how to set up LDAP, everything you will find. So let me just post this into the chat for all users to pick up. So this is available in Spark 1.6, the demo I have given. It is available in anything after 1.6. Sorry. So I'm sending to all, so they can keep mark on my GitHub, and they are free to use it. Reach out to me for any sort of help, any guidance they need. So thank you very much for attending the session, and I hope to see